Syngas, or synthesis gas, is a fuel-gas mixture consisting primarily of hydrogen, carbon monoxide, and very often some carbon dioxide. The name comes from its use as intermediates in creating synthetic natural gas and for producing ammonia or methanol. Syngas is usually a product of gasification and the main application is electricity generation. Syngas is combustible and often used as a fuel of internal combustion engines. It has less than half the energy density of natural gas. Syngas can be produced from many sources, including natural gas, coal, biomass, or virtually any hydrocarbon feedstock, by reaction with steam, carbon dioxide or oxygen. Syngas is a crucial intermediate resource for production of hydrogen, ammonia, methanol, and synthetic hydrocarbon fuels. Syngas is also used as an intermediate in producing synthetic petroleum for use as a fuel or lubricant via the Fischer-Tropsch process and, previously, the mobile methanol to gasoline process. Production methods include steam reforming of natural gas or liquid hydrocarbons to produce hydrogen, the gasification of coal, biomass, and in some types of waste-to-energy gasification facilities. Production chemistry. The main reaction that produces syngas, steam reforming, is an endothermic reaction with 206 kJ per mole methane needed for conversion. The first reaction, between incandescent coke and steam, is strongly endothermic, producing carbon monoxide and hydrogen H2. When the coke bed has cooled to a temperature at which the endothermic reaction can no longer proceed, the steam is then replaced by a blast of air. The second and third reactions then take place, producing an exothermic reaction, forming initially carbon dioxide and raising the temperature of the coke bed, followed by the second endothermic reaction, in which the latter is converted to carbon monoxide, CO. The overall reaction is exothermic, produce a gas. Steam can then be re-injected, then air, etc., to give an endless series of cycles until the coke is finally consumed. Producer gas has a much lower energy value relative to water gas, due primarily to dilution with atmospheric nitrogen. Pure oxygen can be substituted for air to avoid the dilution effect, producing gas of much higher calorific value. When used as an intermediate in the large-scale industrial synthesis of hydrogen, it is also produced from natural gas as follows: CH4 plus H2O CO plus 3H2. In order to produce more hydrogen from this mixture, more steam is added and the water-gas shift reaction is carried out. CO plus H2O CO2 plus H2. The hydrogen must be separated from the CO2 to be able to use it. This is primarily done by pressure swing adsorption, amine scrubbing, or membrane reactors. Alternative technologies. Biomass catalytic partial oxidation conversion of biomass to syngas is typically low yield. The University of Minnesota developed a metal catalyst that reduces the biomass reaction time by up to a factor of 100. The catalyst can be operated at atmospheric pressure and reduces char. The entire process is autothermic and therefore heating is not required. Carbon dioxide and hydrogen, microwave energy CO2 can be split into CO and then combined with hydrogen to form syngas. A method for production of carbon monoxide from carbon dioxide by treating it with microwave radiation is being examined by the Solar Fuels Project of the Dutch Institute for Fundamental Energy Research. This technique was alleged to have been used during the Cold War in Russian nuclear submarines to allow them to get rid of CO2 gas without leaving a bubble trail. Publicly available journals published during the Cold War indicate that American submarines used conventional chemical scrubbers to remove CO2. Documents released after the sinking of the Kursk, a Cold War-era Oscar II submarine, indicate that potassium superoxide scrubbers were used to remove carbon dioxide on that vessel. Solar energy. Heat generated by concentrated solar power may be used to drive thermochemical reactions to split carbon dioxide to carbon monoxide to make hydrogen. Natural gas may be used as a feedstock in a facility that integrates concentrated solar power with a power plant fueled by natural gas augmented by Syngas while the sun is shining. The Sunshine to Petrol project has developed a device allowing for efficient production using this technique. It is called the Counter-Rotating Ring Receiver Reactor Recuperator, or Counter-Root 5. Wind energy. An airborne wind energy system has been proposed to supply heat to the steam reforming reaction. This avoids burning natural gas for the heat and radically simplifies the steam reformer. Electricity. Use of electricity to extract hydrogen from water and then water-gas shift to Syngas has been trialed by the U.S. Naval Research Lab. This process becomes cost-effective if the price of electricity is below $20 per MWh. Renewable sources. Electricity generated from renewable sources is also used to process carbon dioxide and water into Syngas through the high-temperature electrolysis. This is an attempt to maintain carbon neutral in the generation process. Audi, in partnership with company named Sunfire, opened a pilot plant in November 2014 to generate e-diesel using this process. Others, coal gasification processes to create Syngas were used for many years to manufacture illuminating gas for gas lighting, cooking and to some extent, heating, before electric lighting and the natural gas infrastructure became widely available. Although the Syngas chemical composition can vary based on the raw materials and the processes, the Syngas from coal gasification generally is a mixture of 30 to 60% carbon monoxide, 25 to 30% hydrogen, 5 to 15% carbon dioxide, and 0 to 5% methane. It also contains lesser amount of other gases. The Syngas produced in waste-to-energy gasification facilities can be used to generate electricity. Post-treatment, Syngas can be used in the Fischer-Tropsch process to produce diesel, or converted into e.g., methane, methanol, and dimethyl ether in catalytic processes. If the Syngas is post-treated by cryogenic processing, it should be taken into account that this technology has great difficulty in recovering pure carbon monoxide if relatively large volumes of nitrogen are present due to carbon monoxide and nitrogen having very similar boiling points, which are -191.5 degrees Celsius and -195.79 degrees Celsius respectively. Certain process technology selectively removes carbon monoxide by complexation, decomplexation of carbon monoxide with cuprous aluminum chloride, CuAlCl4, dissolved in an organic liquid such as toluene. The purified carbon monoxide can have a purity greater than 99%, which makes it a good feedstock for the chemical industry. The reject gas from the system can contain carbon dioxide, nitrogen, methane, ethane, and hydrogen. The reject gas can be further processed on a pressure swing adsorption system to remove hydrogen, and the hydrogen and carbon monoxide can be recombined in the proper ratio for catalytic methanol production, Fischer-Tropsch diesel, etc. Cryogenic purification, being very energy intensive, is not well suited to simply making fuel, because of the greatly reduced net energy gain. Energy capacity. Syngas that is not methanized typically has a lower heating value of 120 BTU (SCF). Untreated syngas can be run in hybrid turbines that allow for greater efficiency because of the lower operating temperatures and extended part lifetime.